Hey, Algebra 2. Welcome to our videos for section 5.4. We're going to go ahead and factor and solve polynomial equations in this section. Okay, so it's a continuation of our study of polynomials in this chapter. We're going to be in this chapter for another week, maybe a little bit of next week, but then we'll go ahead and start chapter 6. Okay, so the idea of today, our objectives, first of all, is to remember factoring methods from 4.3 and 4.4. All right, so that involves GCFs. Remember, your first step always was to take out a GCF before you factored. That's still going to be the same. So good for you. You don't have to worry about changing that knowledge. Your first step will always be to factor out a GCF. Normal factoring, so when I say that, I mean, like, what if we had x squared minus 3x plus, I don't know, 10. And actually, we'll make that minus 10. So if I wanted to factor that, you would ask yourself, what are the factors of 10? So what are the factors of 10 that are going to add up to -3? And then once we found those factors, then we can write them as this. So in this case, it's going to be 5 and -2. So then the factors here are x plus, I was just getting -5 and +2, my bad. X minus 5, x plus 2, right? Remembering how to do that, and then how to do that if there was an a that was not 1. So, it all goes back to our ax squared plus bx plus c. We're used to factoring stuff that looks like that. And then we also have our special factoring patterns, and I forgot to add one here. Also add here perfect square trinomials, right? We kind of dealt with factoring those as well. And it was those special patterns. These are all special patterns, not all of them, but the difference of squares and the perfect square trinomials. So we had a squared minus b squared. That's our difference of squares. And then our perfect square trinomials, we had a squared plus 2ab plus b squared, and then a squared minus 2ab plus b squared. And then for our difference of squares, that would factor to a plus b, a minus b. Our first perfect square trinomial that factors to a plus b, or also rewrite it as a plus b squared. Same with our other perfect square trinomial. That's a minus b, or a minus b squared. If you have trouble remembering these, I would recommend you write these down again somewhere at the top of this paper that you're writing on for 5.4 notes, because we're going to be using some of these patterns, not just in the examples that we're doing, but you're going to have to use them in your practice set when you work on it in Delta Math, okay? So in case you're someone who has a hard time remembering this, that's okay. I don't expect you to remember it or to memorize it. It helps, but if it's hard for you to memorize it, go ahead and write this down somewhere at the top of your 5.4 notes. That way you can constantly be referring back to it. Okay, so then now on another objective, our second objective, is to use new factoring methods to, now we're going to completely factor higher degree polynomial equations, so degree 3 and above. For now, what we've been used to is factoring degree 2, right? Because everything that we've been factoring so far has been quadratics. So now we're going to apply our knowledge to higher degree polynomials. Okay, we're gonna rock this. So some new methods that we're going to use are factor by grouping. Now we're used to this because we use that in our AC method when we take our A, if we had ax squared plus bx plus c, when we would take our A times our c, and then we would, find the factors of A times c that add up to b, and then separate the bx term into those two pieces and then factor by grouping from there. It's kind of like that, but we won't have to do that extra setup. We'll just factor by grouping immediately, and we'll see what I mean by that when we get there. Sum and difference of cubes, we'll talk about that in the examples when we get there. And then same thing with making something look like a quadratic polynomial. Okay, if we can make it look like a quadratic, then we can go ahead and factor like we've been used to, okay? So let's do a ton of examples, okay, that way we can get lots of practice. So factor the following polynomials completely. Remember, first step always, always is to factor out a what? I hope you're saying GCF, okay? Now, it's not always possible, but whenever you can, that's the first thing you need to look for. So maybe instead here, I should say, look for GCF and then factor it out if you can. Okay, so here in A, we have x cubed. So look at this, this is degree 3, right? Because we have our highest exponent is power of 3. X cubed minus 7x squared plus 10x. What's our GCF here? Now for the coefficients, there isn't one. Our GCF is just 1 because there's nothing that goes into 1, 7, and 10 aside from 1. What about our variables? X cubed, x squared, and x. There is a GCF, right? And the GCF in this case actually happens to be x because each of these have at least an x. When you're looking for the GCF of variables, look for the smallest amount because the smallest amount would be in every single one. Now, if there was a plus 2 at the end, if there was a constant tacked on at the end, then there would also be no variable GCF because this does not have a variable attached to it, okay? So we look for the smallest variable or the smallest power of the variable, which is x. So we factor that out. What are we left with? Divide everything by x. X cubed divided by x is x squared minus 7. X squared divided by x is x plus 10. X divided by x is 1, so just 10. Cool. So now we have to make sure we're completely factoring. So we have to factor until there's nothing else we can factor, okay? So this, let's check to see if we can factor. 10, what are the factors of 10 that add up to -7? So are there any two factors that when we add them up, we get -7? Yes, that's going to be -5 and -2. And since there's no coefficient on x squared aside from 1, we can just factor normally. So we carry down our GCF, right? It's going to stay there. It's not going anywhere. It's tagging along for the ride. And we can factor this into x minus 5 and x minus 2. Cool. So then there's our answer. All right, because we know that once we get to these linear terms, once we get to powers of 1, we can't factor. Okay, that's as we know for a fact. All right, and now always check to make sure that your factors add up to the degree, right? So we have a power of 1, power of 1, power of 1. The total power, if I add them up, is 3, because when I multiply these back together, multiplication of the bases means we add up the exponents. So 1 plus 1 plus 1 is 3. Cool. Let's keep going. Okay, using our same techniques that we've been doing, we're applying it to higher degree polynomials. Next one, we have 3y to the 5th minus 75y cubed. Notice that this is degree 5. Okay, so then our factors, the powers of the factor, the degree of each factor, it should then add back up to 5. All right, so what's our GCF here? Let's see if we can find one. So GCF between 3 and 75, that's going to be 3, because 3 goes into both. Okay, now the GCF between y to the 5th and y cubed, they both have variables, so it's going to be the smallest power, which in this case is 3. So 3y to the 3rd is our GCF. So equals 3y to the 3rd. Okay, what do we have left when we divide that out? 3 divided by 3 is 1. Y to the 5th divided by y cubed. You guys know how to do that now from 5.1, right? We subtract our exponents, so it's going to be y squared, right? You just subtract the exponents, so this is going to be y to the 5th minus 3, which is y squared. And then 75 divided by 3, that is 25. And then y cubed divided by y cubed is just 1. So we're good there. Okay, let's check to see if we're done. We can't factor this anymore, this first thing, because that's just a monomial. There's nothing we can do about that. Y squared minus 25. You see two things. Let's check to see if it's a difference of squares. Y squared is a square. Is 25 a square? Yes, it's the square of 5. 5 squared is 25. So this looks like a squared minus b squared. So it's going to factor into a plus b, a minus b. So then we get y plus 5, y minus 5. And it looks like this is our final answer. Okay, we can't factor this one, we can't factor that one, and we can't factor that one anymore because these are both linear and this is a monomial. We can't factor monomials. That doesn't make sense because, I mean, we could write that as 3 times y to the third, but that's kind of redundant. Make sure that it all adds up back to the 5th degree. So we have 3 plus 1 plus 1 equals 5. Cool. So we're good there. Now let's learn about one of our new factoring methods. We have w cubed minus 27. We can't really do a whole lot with this because if we think about GCF, there's no GCF here. The GCF is 1. So then what do? Well, here's a new factoring pattern. This is the sum difference. Ooh, I can't spell. Difference of cubes, right? So a square is the result of something, is the result of squaring a number. A cube is the result of cubing a number, raising it to the 3rd power. Okay, so sum of cubes, I have a cubed plus b cubed, so a to the 3rd power plus b to the 3rd power. Whenever we want to factor something that looks like it's going to look like a plus b times a squared minus ab plus b squared. Okay, and now if I have something that looks like a cubed minus b cubed, it's going to look like a minus b, a squared plus ab plus b squared. Okay, the last sign is always positive, and then these first 2 signs are the ones that are switching. The first one is the same as the original problem, and the second one is opposite. Okay, so a cool thing to note about this pattern is that this and this is always prime. Okay, which means we can't factor anymore. All right, so when you use the sum difference of cubes, that's pretty much your final answer. You don't have to worry, because normally if we get a quadratic, we would have to check and make sure that we can't factor anymore. But these are always going to be prime. We cannot factor them, okay? So then let's apply it. Let's see how that works. Okay, so w cubed minus 27. Let's identify, first of all, it's gonna be our difference of cubes, if it were to work. Now let's just make sure that we can rewrite it as something to the 3rd power. Well, the first one is all set, w cubed, in this case you can say a is w. Now, what is b going to be? Can I write 27 as as a number to the 3rd power? We'll check really quick, see if you can figure that out. Is there a number that you can raise to the 3rd power to get 27? Okay, pause for a second. Hopefully you're finding that it's 3. Yep, 3 to the 3rd power is 27. 3 times 3 is 9. 9 times 3 is 27. So our b is 3. Okay, let's apply this pattern. So this is going to equal a minus b, so w minus 3, a squared, so that's w squared, plus a times b, so w times 3, that's better known as 3w, plus b squared, 3 squared, 9. And we are all set. Sorry, that was a really wide thing there. Okay, very good. So once you apply some difference of squares, that's really all you can do. You can't really factor it any further, okay? So you can take some solace there because then you know that you don't have to check to make sure to keep going. Because normally if you end up with a quadratic factor, you should keep going and checking to see if you can factor it. Let's convince ourselves. What are the factors of 9 that add up to 3? Impossible, because the only factors of 9 are 3 and 3. Oop. It's either 3 and 3 or 1 and 9. And since it's positive, positive, they all have to be positive. And there's no 3 plus 3 is 6, 1 plus 9 is 10. So there's no way I can get that combination. Okay, let's keep going. Let's keep going. Let's apply this sum difference again. All right, so we'll do example D, and then we'll do D, and we'll see. We'll see how long D takes us. So D, if you notice, let's first, I just almost forgot as well. What's our GCF? Okay, what can we factor out of 16 and 250? Well, let's always just check, can I factor out the 16? 250 divided by 16? Nope, that does not work. So let's think smaller now. What are some factors of 16? I know there's 2, 4, 8. Maybe let's just start all the way at the bottom with 2. Does 2 go into both 16 and 250? Definitely goes into 16, and it definitely goes into 250 because 250 is even. Now let's try 4. 250 divided by 4. Nope. 250 divided by 8. Nope. So then our GCF is 2 for the coefficients. What about the variables? It's going to be the smallest power, so b squared. So 2b squared. Factor out of 2b squared. Divide everything by 2b squared. So 16 divided by 2, that's 8b to the third, plus 250 divided by 2, that's 125. B squared divided by b squared is 1. I think I might have skipped it, but b to the fifth divided by b squared is b cubed, in case I didn't say that. Okay, so I have a cubic. Here's our 3 plus something. So let's check. It looks a lot like it could potentially be a cubed plus b cubed. Okay, let's check to see if it does work. Can I write this as an a, and can I write this as a b? Can I raise something to the third power to get 8b cubed? Well, I know I can take b to the third power to get b to the third power, right? Is there anything you can take to the second power, or sorry, to the third power to get 8? What times itself gives you 8? It's 2. So this is 2b to the third power. Now what about, oh, this is a terrible problem because we have b's here. Okay, well, I didn't think ahead, so let's just kind of modify everything a little bit because that's kind of gross. Because then you won't be able to keep track of which b is which. Okay, let's use, let's just be normal for once in our lives. Let's just use x. X, 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 x. And then same thing here. Let's make this an x. Okay, now everything is right with the world. So a is 2x. That way we don't confuse ourselves with the b. So now with the b, with the actual b, oh, forgot to change it in the GCF too. Is there anything you can raise to the third power to get 125? Yes, we can raise 5 to the third power. 5 times 5 is 25. 25 times 5 is 125. Okay, so this looks like, sorry for writing in white all of a sudden, even though I was writing in blue. So now this is definitely a sum of cubes. And if you remember from our pattern, that's going to be a plus b, a squared minus b, minus ab. Okay, minus ab plus b squared. Let's rewrite it like that. So parentheses, a plus b, 2x plus 5, a squared, that's going to be 2x squared. I'm going to write it out like that just so we can do it correctly. Minus a times b, so 2x times 5, 2x times 5, plus 5 squared. Okay, equals, oh, don't forget 2x squared in the front. Let's attach that, so 2x squared 2x plus 5, 2x squared, that's 4x squared, minus 10x plus 25. Okay, let's double check to make sure the degree adds back up. We have a 2, a 1, and a 2. 2 plus 1 plus 2 is 5. Perfect. Okay, so that's kind of these are the kind of ways we can see our sum and difference of cubes. Sorry for the little hiccup with the b and the b. Just wanted to make sure it wasn't confusing, so I went back and changed it a little bit. I apologize for that. Meet me in the next video. This one kind of already took enough time. Meet me in the next video and we'll look at a few more methods, okay? And then we'll also solve these equations.